All right, so we were talking about the craters on the moon in the last video. The craters have been going on. These impacts have been going on, um, since the solar system, well, since the moon formed, really. Uh, but most of the craters, okay, so we think that most of them have, they all, not they all, but most of them appear much softer, which means that they're older. There are some relatively fresh craters on the moon. Uh, there was a period in our solar system called the Late Heavy Bombardment. It actually has a name, and we think that that's when there were tremendous amounts of material coming into the inner solar system um, you know from the outer parts of the solar system, uh, you know, asteroids, comets, and so forth. And in fact, that may be why there's so much water on the Earth. It came from that early period called the Late Heavy Bombardment. So this is early in the solar system's history, within the first billion years or so. So that's where you get most of these craters. Um, all right. Here you can see. So there's also these canyon-looking things called riles. Just remember, just be aware that there are these canyon-looking things, and we think that these are ancient lava flows, as it says here, where the crust cracked. Um, again, if we don't think that there was any recent. Actually, and I should I should preface that actually. There was, in science, there's always a chance that new information, new experiments, new observations will change things. For a long time, I've been teaching this for a very very long time, and we have assumed that there hasn't been any lava flows on the surface of the moon, breaking through the surface of the moon for you know uh, for at least 3 billion years. But there was actually a recent Chinese spacecraft. I forget the name of it, but there's some of the evidence. And it's not like this still has to be fully peer reviewed and everything. It takes time in science for an idea to fully take form. Um, for all the evidence to come in for it to be you know for it to be accepted by the scientific community. But right now, preliminary evidence by this mission, this one mission, and again, it'll have to be verified probably by other missions to the moon, show that perhaps the moon has had more recent volcanic activity within. I think I read that they think that it was just maybe a few 100 million years. That's quite a difference between saying that the moon hasn't had any kind of lava flowing across it for 3 billion for the last 3 billion years, and just say no, it happened a few million years ago, or even a few 100 million years ago. I mean, that's quite a difference in time. All right, so again, that has to be verified. All right, so again, I mentioned this before, but I just want to make sure that the lunar features that we see, the craters, the maria, the rays, are the result of impacts of the early moon. Maybe there's lava there's been lava more recently. That still has to be verified. Again, it'll probably take it'll take a long time for if that turns out to be true, that those observations that one Chinese spacecraft has made on the moon, if that turns out to be true, there'll be other, there'll be more evidence that we're always interested in accumulating as much evidence as we can. All right, but for right now, we're just going to go with the fact that, or we're going to go with the idea that the moon has been inactive for the last 3 billion years or so, and the features that you see on the moon are from impacts. Most of the impacts taking place, more than 3 billion years ago. All right. What else? So the circular craters form when high velocity projectiles disintegrate upon impact, and it makes a cloud. And you can see that. I mean, that's exactly what you see. These are giant. These are impacts. The other thing that I want to mention is the Earth has had at least as many impacts, probably more, in fact, because the Earth is more massive, so more stuff is going to hit the Earth than hit the moon. So why is it when we look at the moon, it has all these craters? Where are those craters on the Earth? The Earth has weathering, right? So over time, over just a short amount of time, the weather on the Earth will erase these impacts. For example, there's an impact crater in the middle of the desert in Arizona called Meteor Crater, with the name Meteor Crater. Okay, we think that crater, the impact took place about 50,000 years ago. The evidence shows that it's about roughly 50,000 years old, and even that is going to eventually, in the next million years or so, you won't be able to tell that there was an impact there just due to weathering, even in the desert, which doesn't rain all that much. All right, so this is one of the Maria. This is Mar Oriental. Is just showing you that there's been multiple impacts that just coincidentally have happened in this one region. Let's see, radiometric dating places the resulting lava 1.2 billion years after the moon's formation. So if you assume the moon formed about 4 billion years ago, that's not a bad assumption. It's probably a little. It goes back even further than that. But the first billion years of the moon's history, there was actually lava that would break through on the surface. We'll get to that actually. That has to do with the formation of the Maria. All right, so we'll talk about that in a second. Oh, that's actually the next slide. Okay, I thought that was a little further along. Okay, so how do you get the Maria? All right, so let's look back right here. All right, so you have these huge dark regions. I mean, you can just look up at the moon. You see these dark regions, and you see these lighter regions. And so, what's going on here? Why did this happen? All right, and so the explanation that we have, all right, it has to do with really large impacts. And so these large impacts crash through the crust, break through the crust in the early history of the moon, right? So this is within the first billion years of the moon. But by the way, in the early parts of the solar system, there were much larger objects hitting each other. Everything was hitting everything else in the early solar system. In fact, that's how the moon was formed, we think. But at any rate, you have these larger objects breaking through the very thin crust, and the mantle of the early moon would have caused lava to break through the crust and fill up the crust, and then solidify, right? Then cool off. The lava would cool off, and that's that's why the Maria are made of the Yes, and so the lava solidified, it becomes a basalt, right? And that's why the Maria are made of basalt, right? And the yeah. So all right, let's move on. The structure of the moon. The moon lacks the folded mountain ranges, and that the reason that there's folded mountain ranges on the Earth really has to do with plate tectonics, um, and that's not going on with our moon. All right, so the like we said, the moon, or like I said earlier, the moon is more or less a dead world. Um, Although, if this if that the observations from that Chinese spacecraft turn out to be right, I'll be changing that in the future. Certainly, if the moon had volcanic eruptions, you know, just a few million years, a few 100 million years ago, that would make a huge difference in our explanation for the moon. All right, so that still has to be fully verified. We're kind of a long way off from that. All right, so the moon has a much higher its surface area to volume ratio. It's good because the volume of the moon is so small, and therefore it's lost a lot of heat. Compared to the Earth, holds on to its heat, and of course there's less radioactive material just because there's less mass on the moon to keep the interior of the moon warm. What is this? The interior of the moon, including the crust, with their study so the astronauts actually brought up seismic detectors, just like we have seismic detectors on the Earth, measuring volcanic activity. We've seen small little moonquakes, but nothing to indicate, of course, that the moon is an active world, right? And all that means, of course, is that the interior of the moon is not hot enough to drive plate tectonics the way plate tectonics is driven on the Earth. All right, so there is, of course, a little bit of there's a higher temperature inside of at the core of the moon, but it's just not high enough to drive plate tectonics. All right. So now we'll talk about a little bit about the interior of the moon, and it's actually a very relatively simple. There's a crust, there's a mantle, and we think that there is a core. There might be an outer. There's no overall magnetic field. So if the moon does have a liquid core, it's really small, and there's not it's as it says here. I think it might be iron sulfide instead of just pure iron and nickel the way the Earth's is. The solid core is iron and nickel. We think, well, it's not. We think we measure the density of the moon, and we know what we know what the rocks on the surface, what the average density of the rocks on the surface are, and we can estimate what the core and also estimate the size of the core and everything. Let me mention this stuff called regolith before this particular video ends. Regolith is a result. First of all, let me just say what it is. It's a result of like little tiny micrometeors hitting the moon over and for the last 4 billion years, and hitting the rock over and over that makes up the surface of the moon. Remember, there's no there's no atmosphere that would burn up these little micrometeorites. Like that's exactly what happens with the Earth. So anything that is heading towards the moon will hit the moon, and it breaks up the rocks a little bit. And over time, you have this powdery stuff. It's kind of like talc, almost the same consistency of talc. This was a pain in the neck for the astronauts. They got it all in their clothing. in their boots, and when they got back onto their spacecraft,